This time, let's run Michelangelo, another new program that I wrote this past year. So Michelangelo is the famous statue, Greek statue, and what one of the basic programmers in the Facebook basic group had written was a program to do 3D vectors on a Commodore Plus/4 computer of the Michelangelo statue. And I asked if I could use his data file, and I created a program to have Michelangelo be drawn in vectors, and so we'll see that first, and then where every one of the polygons is shrunk a little bit and filled so it looks more like a Iron Man costume on Michelangelo. We're going to view the file with vectors only. And you notice the flash as the vectors are drawn, the polygons are drawn with fast graphics. And we're done. This computer has a 11-inch diagonal screen compared to the 19-inch that's on the 4054A, and when it draws, it takes the same time to draw a line from corner to corner of the screen as it does a really short vector like some of the ones in Michelangelo. My 4054 video of this program shows much faster drawing speed. It's the same processor in both computers, but the display architecture in the 4054 has constant speed, meaning a short vector draws and finishes quicker than a long vector. And so all these short vectors get drawn really fast on the 4054A. Let's go back and run the program again, and this time say we want to fill the polygons and see that version of the file. Now it's taking longer because after it draws the outline of a triangle or a four-sided polygon, it then draws a line from bottom to top of that polygon to fill the vector shape with a solid green. The Commodore program worked completely different because the developer was using the bitmap graphics in the Commodore, which is most PCs today, all of them have bitmap graphics. And so he was just able to draw black lines instead of green lines around the outside of the polygons to get the view that we're going to see. And of course we're drawing an enormous number of vectors compared to just the outline version of Michelangelo, and so it's taking longer to finish. And my algorithm in my basic program to reduce the size of each of the polygons results in the very smallest ones have the shortest gap to the next, to every edge, and the largest polygons have the biggest gap. So right in the middle of Michelangelo's chest is a big diamond polygon that seems to have a much bigger gap than most of the other smaller polygons. Almost done. It's done. Let's go back. The other thing the program can do is actually read the raw data file and create each of those vectors, which that took a long time. Alright, hope you enjoyed this video, and I'll be posting more on my channel soon.